Hey guys, I'm Ashwell the Brilliant, and you're watching Learn with Ashwell. And I'd like you to accompany me on this journey of knowledge, as I'm a student myself, and I know the psyche of students. I have decided to make these educational videos as a lot of my fellow students have a hard time connecting to the subjects. I know there are a lot of great teachers out there doing great work, but students still have a hard time connecting to the subjects. And I feel that when students can connect to the subject, they'll understand better, they'll study better, and they'll have better grades. In my topic intro videos, I will elaborate on the theory and background part, and those will be the most important videos as they will build your concept. And once you have the concept, then the exercises will be like a cakewalk. So, our today's topic is quadratic equations. So we will try to learn what quadratic equations are. So let's get going.
Equations. Let's understand what are these equations we hear and use so often. Equations are relationships between two or more quantities, and that's their English definition, you could say. And in math, they are defined as relationships, basically those quantities that we're talking about, these quantities, they turn into terms when we're talking in math. So between relationships between two or more terms, these are equations. Now, you probably might not understand, right? You might not think that, hey, how is this possible? So let me give you an example. So say that you have five oranges, and you have 10 apples. This is just like a simple example in which I'm just trying to just get you to understand what I'm trying to tell you. It's not even that complex or hard to know what's an equation or to recognize one. As you can see, over here, 5 oranges and 10 apples, and let's say if I say the weight of these 5 oranges is equal to the weight of these 10 apples, then this is an equation. Why? Because there's an equal sign, and the equal sign is basically telling us that it's like relating these two quantities, which are like 5 oranges and 10 apples, in the sense that their weight is equal. So that's the relationship. So now, if that's one equation, and that's one example of an equation. Now, if I say that one of these oranges, let me just change the color real quick. One orange is equal to, or you could say costs $2, and I say 5 oranges, that means that 5 oranges must cost $10, right? So I mean, obviously this is really easy, right? This is simple, just unit rate. But what I'm trying to say is that you can see over here, first of all, you can see this, as you already know, this is an equation. And I just drew two more equations. One orange, its cost is $2. This is an equation. And 5 oranges, their cost is $10. That's another equation. So these are two equations. It's just a relationship again. It's just showing us the relationship between the orange and its cost. Now, if I take the example from physics, the example of speed, in which the equation is speed equals the speed of an object equals the distance traveled by the object divided by the time that it took for the object to complete travel that distance. So that's the relationship, and let me write it. Speed, how did this become an equation? How did this change into equality? Well, it was the original statement, you could say, was that speed is proportional, directly proportional to distance. And when something is proportional to another thing, like two quantities are proportional to each other, and especially directly, like over here distance is directly proportional, so that means that as one quantity changes, the other one changes as well by, you could say, the same thing, the same, like, whatever. You could say, like, if it changes by 1, then the other changes by 1, or if the other changes by 2, so like that, like by 2 of the same factor, you could say. So, like, this is true when time is constant. So that means that if the time stays the same, time is constant meaning time stays the same, then the speed, meaning the more speed an object has, the more distance it can cover. That's what this proportionality is telling us. And when we bring it into an equation, time is the constant that we need to bring it into. Remember, guys, every proportionality that we have to use a constant. We need a constant to turn it into an equation. But obviously, this is for later. I'm just telling you just briefly so you know what we're doing. But basically, this is for another chapter and another video, and I'll tell you that later. But yeah, for now, let's try to relate time and distance now. So if we send speed down over here onto the other side, basically it'll be dividing, and time to the other side will be on the top. So we'll get time equals distance, meaning the time taken by an object to cover some distance, is equal to the distance that the object travels divided by the speed that the object travels the distance at. So over here, again, there's another proportionality, and it's still direct. We're just going to talk about direct for now. So time is directly proportional to distance when the speed is constant. So that means that the more time, what do we call it? Yeah. The more time it'll take if the distance is more. So, like, for an object to travel, the more time it takes, the more distance it has to travel, and provided that speed is constant. Yeah, so meaning that if, like, it takes less time, then it will travel less distance if the speed is constant. And right, constant. So yeah, that's the physics equation. And now let's move on to algebraic equations. Algebraic equations. So what are algebraic equations? Algebraic equations are just equations, just like general ones, just that they have a variable within them, and they work the same way, like just that you have a variable and you can find its value. That, like, let me write an example. So, like, an example of an algebraic equation can be like if you have something like x plus 3 equals 5. This is an algebraic equation. Now, why are we using x? We generally use letters like x, y, and z because these are usually used, and because the letters A, B, and C, they're usually constants. At least their values, they're usually constants in algebra, so that's why we use variables. For variables, we use x, y, z. And yeah, let me write some more examples. So if you have something like 3x minus 1 equals 8, this is another equation. So now, one more thing. All the equations that we've mentioned up till now are called linear equations. And linear equations, what this means is that linear equations are equations, that all looks a little... So, linear equations are basically equations that, like, the highest power in which the highest power of the variable, say like the variable is x, the highest power is 1. And that means what this power is indicating is that there's only one value of 1, meaning one result. When you solve the equation, you'll get one result of 1. And that's kind of true. If you see over here, if you take 3 to the other side, then you'll get only x's value, right? If you take 1 to the other side and then you divide 3 on both sides, then you'll get the value of x as well. So I mean, there's only one value, right? You can see. So, like, that's what it means, linear equations. So, next time if you see or hear something like linear equations, then that means that those equations and those equations, you're supposed to get one value. Now, that's enough algebra for today, I guess. Now, let's move on to our topic today, which is quadratic equations. Quadratic equations. And what are quadratic equations? Well, quadratic equations, first of all, I'm going to take the word quadratic, and from it you can see there's quad. What does quad mean? The word quad, it means square. The means square. And you might be wondering, wait, square of what? Square of the variable. This variable. Square of the variable, I just told you variables are like x, y, z. So you'll have something like x squared or y squared or z squared, something like that. You'll have something like that in the equation because that is what makes it a quadratic equation, because they'll have squares. You can see squares. So let me write an example now. Let me write a few examples of quadratic equations. So you have something like x squared plus 2x minus 4 equals 0. This is a quadratic equation. Why? Because there's x squared over here. Let me just write 2-3 examples. We have, say, 3x squared minus 7x plus 5 equals 0. Again, it's a quadratic equation because of the square. I couldn't circle the property. There we go. If we have something like 5x squared plus 15 equals minus 10x, it's still a quadratic equation because, again, you can see we have the square. And one last example I'm just going to write. If we have something like 7x squared equals 10, actually let's say like 21x plus 14, this is a quadratic equation. Why? Because it has the square of the variable again. Now, these two equations, you can see they're written in like a certain way, and this way of writing quadratic equations is called the standard form. Standard form. And what is the standard form? The standard form is like if you have something like ax squared plus bx plus c, meaning like not saying that like if you have something in like this exact form. I'm just saying like in this form you have to understand that a is the coefficient of x squared, b is the coefficient of x, and c is the constant. And this is only true provided that a is not equal to 0. Because if a is equal to 0, just saying, imagine if a was equal to 0, what would happen? The x squared term would be 0. And if the x squared term was 0, then there would be no quadratic equation, right? Because there's no variable with a square. So a has not to be 0, meaning I just messed up my grammar right there, but yeah, it cannot be 0, okay, guys? So next we have a, b, and c. A, b, and c are real numbers, mate. So they're real numbers. And yeah, that's the standard form. So if we have something in this type of form, now what you can see over here, you'll notice that like since I told you before why we use constants and why we use variables only with like x, y, z as variables, and why we use constants. So as you can see, that a, it's like I told you before, is the coefficient of x squared, and b is the coefficient of x, and c is just the constant. So over here, if we see something like that over here, I think you can see over here, wherever there's nothing with the coefficient, then there's 1. I mean, nothing as a coefficient, then there's 1. So over here, there's x squared plus 2x minus 4. So over here, there's an x squared term. There's an x squared term over here. So yeah, that's right. And there's a is basically 1 because where there's nothing I just said, there's 1. So you have that. There's a. Then for the x term, there's bx. So b is a coefficient of x. We have 2 as a coefficient of x, right? We have c as the constant. By the way, this doesn't really matter. I'm just saying like why you write it, like how you write it in the standard form is like there's 0 on one side and all terms on the other side. Provided that like you have to try and make the x squared, you like have to make its coefficient positive, or like it's basically value positive, so its coefficient has to be positive for that, right? So like if you have like minus 3x squared, then you had to take it to the other side to get it positive, right? And one more thing is that like x squared, whatever like side has x squared with the biggest or largest coefficient as positive, meaning like if you have like 5x squared on the left hand side and you have minus 3x squared on the left hand side, or say that you have like 5x squared on the left hand side and you have like 3x squared on the right hand side, then what? Then you had to take 3x squared to the like 5x squared because 5x squared is bigger. So yeah, that's another thing. And yeah, basically these are in standard form. So these are in standard form, as you can see over here. Let me just change the color. And these we can write, these ones we can write in standard form by taking 10x to the other side in this case, minus 10x. So when it goes to the other side, it will become plus 10x. And over here, we'll have to move 21x and 14 to the other side. So when we move both of these, their signs will change. And over here, you can see both of them are positive, so both of them will become negative when they go to the other side. And let me just write it down. So we'll have 5x squared plus 15, and when minus 10x goes to the other side, it will be plus 10x equals 0. Just draw a line to separate these. And yeah, so in the next equation we'll have 7x squared minus 21x minus 14 equals 0. And yeah, done. These are quadratic equations now in standard form, all of these. So that's good. Now there's another thing. Now if you have something like say 3x squared minus 9 equals 0, or if you have something like 2x squared minus plus 7 equals 0, or if you have something like 5x squared minus 8 equals 0, what now? Yeah, I mean like it is a quadratic equation, right? Like you can see over here there's x squared, there's x squared, there's x squared, but there's something's missing. I think, as you can see there, the b term, the x term, actually the x term is missing over here. And you're probably thinking where to go, right? Well, I'll tell you where to go. So let me just write it again in the standard form. I'm just going to write first ax squared plus bx plus c equals 0. So sometimes what happens is that sometimes b is equal to 0. So what now? If b is equal to 0, that means the x term is garbage, it's trash, it's done, right? Because when 0 multiplies, when b is equal to 0 and b is the coefficient of x, meaning it's going to multiply with x, so then 0 multiplies with x, it'll be 0. So no point in writing that. So you'll get ax squared plus c equals 0. Look familiar, doesn't it? I think, yeah, you can probably tell by now that it's the same thing over here, right here. These equations are the same as this, so these are the same. And they have something in common, as you can see. Obviously, there's ax squared and plus c. I mean, it doesn't really have to be always plus, but like that's the version you got to write in plus c. But like the constant can have a negative sign. It doesn't really matter. So yeah. So what now? What is this? This is a version of a quadratic equation. It's called the pure quadratic equation. Pure quadratic equation. And it's a quadratic equation in which, like, there's basically, you could say it's a condition that b has to be 0. When b is 0, then that means the x term is 0, and when the x term is 0, that means you'll have something in the form of ax squared plus c. And when you have something like that, that means that that's a pure quadratic equation. So all of these are pure quadratic equations. Now, if you have something like, say you have something like x squared plus, say 6x equals 0. What about now? Does this have another name? Well, it doesn't really have another name, but you can still tell that it's a quadratic equation because there's an x squared. I mean, yeah, fine, there is no constant, but there's no other name for that. We don't have a separate name for everything, you know. But like, yeah. So x squared plus 6x equals 0. That's another quadratic equation. Okay, so now we have hidden quadratic equations. What are hidden quadratic equations? Just like the name implies, they're quadratic equations that are hidden that we can't really see and we can't really tell. Like, meaning we can't really tell if we can't really see, so we can't say that there's an x squared, right? So, like, just like that, they'll be hidden to the eye. We can't really tell, but we can solve them, and we can tell if we solve them using simple mathematical operations. We can get a quadratic equation, meaning we can get an x squared. Now, here are some examples. Let me write some examples of hidden quadratic equations. If we have something like x plus 1 over x equals 7, or something like x plus 3 plus 1 over x plus 3 equals 5, or we have something like x plus 2 over x plus x over x plus 2 equals, say, 4. Then these type of quadratic equations, they're like hidden because we can't really see. Why I'm calling them quadratic equations is because I can type of tell that if we use some mathematical operations, we can get a quadratic equation. But for you, it might not look like that. You might not see a quadratic equation, and that's fine. But what we gotta do is we gotta solve it so that we can see a quadratic equation. Now, you can see that there are fractions involved in this, and when there are fractions, we want to get rid of the denominator so there are no fractions most of the time. So how do we do this? We first of all, number one, we can simplify one side, which has the fractions. Like, for example, if it's on the right hand side, we solve the right hand side. If it's on the left hand side, we solve the left hand side. Whatever we have, we individually solve them on each side. Or if you have, like, say you have like 2, 3 fractions, then you could also, it's basically just your choice, but yeah, you could also take the LCM of the equation, which equals the product of the denominators. I'm writing D for short, but the product of the denominators. That means that if you have something like 1 over 2 plus 3 over 4, I'm just giving a simple example just to tell you that this just works the same way as you would solve regular fractions. Like, if you have these type of fractions, what do? First of all, you take the LCM. Say right now it's 4. and this is the LCM, so we're going to divide the LCM to find out what multiplies with each of these. We'll divide the LCM, which is 4 over here, by first we're going to divide by 2. So when we do that, we have 4 over 2, and as we know, 2 1s are 1 and 2 2s are 4, so we'll have 2 left, and 1 will multiply with 2. Next we have this plus sign, then we have 3. What will 3 multiply with? We have this denominator. It's going to divide the LCM. So 4 is the LCM, and 4 is also the denominator, the second denominator. And when you divide, you get 4 1s are 1 and 4 1s are 1. So you basically you get 1. So you'll get like 1 into 3, which you don't really need to write. But that's exactly how this works, how fractions over here work. And as you can see, now I'm going to tell you that what are the LCMs of these equations. Like for example, over here there's let's say over here we have x plus 3, and whatever does not have a denominator is there's always 1 for it. So we have 1 and 1. So when 1 and 1 multiply, it doesn't really make a difference. So basically the LCM is x plus 3 for the second equation. And for the third, we have x at the bottom and we have x plus 2 at the bottom. Those are the only two denominators. Over here there's nothing, so there's 1. So when 1 multiplies with these, there's no difference. So these, x into x plus 2, this is the LCM of this equation, meaning that you have to multiply this term, x into x plus 2, with each of these terms, like x plus 2 over x. When you multiply it with x plus 2 over x, the first term, x and x will cross out. You'll get x plus 2 into x plus 2, or x plus 2 square. And then you have this plus sign, and basically this is the second term, which in the second term, x plus 2 and x plus 2 will cross out, and you'll get x into x, or x squared. And in the third term over here, when it multiplies, there's nothing that can cross out, so you'll have 4 into x plus 2. Right, now let me just solve for you x plus 1 over x equals 7, just to tell you, just to show you like how it actually works as well. So we have x plus 1 over x equals 7, and the LCM of this equation is, as you can see, there's only one denominator. The others are basically just 1. Over here there's 1, over here there's 1. So we only have x. When x multiplies with x, the first term, we get x squared, when basically it's x into x. So yeah, then we have plus. When x multiplies with 1 over x, x and x cross and you get 1. And then you get equals to 7 into x will be 7x. But as you can see, you could probably tell when I wrote x squared that it's a quadratic equation because of the x squared. So yeah, that's basically just hidden quadratic equations, and that's what you can do to solve them. And yeah.
That's it for this video, guys. I hope it was helpful. If you have any confusion, question, or comment, shoot me a message and we'll spend more time on it. And you might want to ring the bell so you get notified whenever I release a new video, and I'll be trying to do that every week. And share it with somebody that you know if you think it's beneficial for them. And yeah, peace out.